This conference will now be recorded.
Very good morning, students. We have been discussing ray optics. So today, the topic we are going to discuss is telescope. So, what is a telescope? Telescope is an optical device which enables us to view distant object clearly. So you might be thinking, what are the distant objects we can see? We can see distant object like from your terrace, you can see the tower of something, or you can just view the moon or the sun and many other things in the sky as well. So telescope actually enables us to see distant object clearly, but what it does actually, it actually provides an angular magnification. That means, so we have seen this angular magnification in case of microscope as well. In case of microscope, this is actually totally different. In microscope, you see a small object as bigger. In case of microscope, in this case also you see in this case you see distant object. Okay, obviously here also we see things in a bigger font or bigger size, larger size. If you see your naked eye, this is the dimension of moon maybe, but if you see in the telescope, you'll see in a bigger size, okay, or larger size. Okay, so then you can see everything, every details very clearly and very neatly. You can see the details in that. Okay, generally the satellites of Saturn and others can be viewed through this. And you know, okay, we'll, as we go along, we'll discuss many more things. Okay, so we have learned what is telescope and what actually a telescope does. It actually increases the angular magnification of any distant object. So that is the job of a telescope. Now we'll see there are different types of telescope. Okay, construction wise, telescopes are of two types. One is refracting telescope, another one is reflecting telescope. So when I say refracting telescope, that means the phenomenon of refraction of light is being used in this type of telescope. So the refracting telescopes, they uses lenses, okay, lenses. Okay, so refracting telescopes use the refraction phenomenon of light, and hence they have to use the lenses for construction. And reflecting telescope uses the reflecting properties of light, so it has to use mirror. So here basically converging mirrors are used, okay. Converging mirrors are used. All right, so now among these refracting telescopes, okay, reflecting telescope, there are some examples of reflecting telescope like Newtonian telescope and Cassegrain Cassegrain telescopes. These are reflecting type, okay, where the converging mirrors are being used. Okay, so among refracting telescopes, use like the utility wise, there are two types of refracting telescope. Okay, so there are two types of refracting telescopes. One is astronomical telescope. This is in terms of utility. Astronomical and terrestrial. Okay, terrestrial. So what are astronomical telescopes? Astronomical telescopes are those which are used to view the heavenly objects. Okay, to view the heavenly objects like sun, moon, stars, planets, etc. So these are used to view heavenly object. Or astronomical objects. Okay, so one telescope you can name in this category is the Hubble's telescope, which actually is accessed by or set by India. Hubble's telescope. Okay, Hubble's telescope. And the second one is terrestrial. Actually, this is being used to view objects on the surface of the earth or near the surface of the earth itself. So in case of astronomical objects, say astronomical telescopes, here the image formed is inverted and real. So astronomical objects are inverted and real in like the image we get in astronomical telescope will be real and inverted, but that doesn't matter because most of the heavenly objects are of round shape, right? If I see this side and that side, that doesn't matter, or this side up and like this side down and this side up, doesn't matter. Okay, so mostly all the heavenly objects or astronomical objects are of round shape, so doesn't matter if we see the inverted image of that. But in case of terrestrial telescopes, the final image is formed is erect image. Okay, so it is necessary. Suppose you are watching some cricket match from little far in the ground, but you see a player is running in the inverted way. Okay, if you see the running player inverted, then you won't get that feelings. Okay, or that would be a little bit absurd. So therefore, in the terrestrial telescopes, the final image is actually erected image. And that is actually essential condition for terrestrial telescopes. Okay, so this is about the various types of telescopes. Now we'll just see, we'll basically discuss this astronomical telescope in details, like the image formation, and we'll find out the magnification or magnifying power of the astronomical telescopes. So this. So today's discussion will be on astronomical telescope. We will not go into very detail, but reflecting telescopes we will see again in detail. Okay. So I think this is there in the syllabus, astronomical telescope, like magnifying power of astronomical telescope. Okay, let us then discuss astronomical telescope now. So astronomical telescope, as you have already learned, these are used to view the astronomical objects or heavenly objects, and these are actually refracting type. Okay, refracting telescopes. Refracting telescopes used for viewing let me write used for, okay, used for viewing okay, I'm directly writing on stars, sun, moon, and other planets, etc. These are actually astronomical objects. Astronomical objects. Okay, so let us now see the construction of this kind of telescopes. As you know, a refracting telescope means it will be constructed by lenses, spherical lenses. So here, you know, we have already learned in the microscope, compound microscope, there are two lenses. So in telescopes also there are two lenses. If I show you the figure, you can see here. Maybe I'll erase this writing part. Okay, this part alone. Okay, so astronomical telescopes consist of two converging lenses or two convex lenses. See, one is acting as objective lens, which is facing the object. This is the distant object. So the objective has larger focal length. So I'll write it here. Objective lens. So objective lens, objective, this is actually both are convex lens only. So objective actually faces the object. Okay. So it faces the distant object. Distant object. Okay. Then it has large focal length. Okay. And third and important point is it has large aperture. Okay, large aperture. Why do you need this large aperture of this objective? Because you want to see a very prominent image, right? And to have a very bright and prominent image, and to see everything very prominently or clearly, the image has to be bright, isn't it? So for that you need as much as possible, okay, the amount of light the objective has to collect is very large amount, okay. So objective is having large aperture to collect or gather a large amount of light from the distant object, or sufficient amount of, it has large aperture to gather sufficient light from distant object to have bright image. Okay, so this is about objective lens. Now we'll see there are other lens, which is the eyepiece. This is similar, very similar to, like, at least the construction part, similar to compound microscope. Okay, but there are differences as well. We'll see that. So eyepiece is having, see, this actually faces, see, eyepiece faces the eye. Okay, that means we see through this eyepiece. Okay, so the objective is actually collecting the rays or light from the distant object. Okay, and we see the image through this eyepiece, which is near to our eyes. Okay, then it has smaller or small aperture, and it has comparatively shorter focal length. Okay, eyepiece always needs, like, to have larger angular magnification. Focal length, see, focal length of this eyepiece is FE, will denote, and focal length of this objective is denoted by FO. So FO always needs to be larger than FE, okay, for having better magnification. Okay, that will derive and see when we derive the magnifying power, etc. Now see, we have discussed the construction part. Now we'll go to the use of the telescope, astronomical telescopes. See, astronomical telescopes can be used in two ways, as we have seen in case of microscopes as well. So we can set the telescope such that the final image is formed at the least distance of distinct object, sorry, least distance of distinct view or distinct vision, and the final image is formed at infinity. So there are two uses, like two settings of the telescope, just as microscope we have learned already. So first we'll discuss when the final image is formed at the least distance of distinct vision. This is the corresponding figure. You can see that. See, as I I had discussed, we have a large objective. This is the distant object. You can see that AV. So parallel, see, since it is at very large distance, so the rays which are coming or rays which incident on the objective will be parallel rays. You can see that. So these are parallel rays. Okay. So these parallel rays are incident at some angle alpha at this objective. Now this objective lens is actually, since these are parallel, and you know these are not parallel to the principal axis, these are oblique to the principal axis. That's what I am saying here, that the parallel rays are incident at certain angle alpha with the principal axis. So then the image will be formed at some focal plane. So the image will be formed at the focal plane of this objective lens. So you can see this is FO, that means this is the focal length, sorry, focal. So this much is the focal length, you see here. This much is the focal length of this objective. So FO is the focal length. And what is focal plane? So the plane passing through the focus, okay? Passing through the focus and perpendicular to the principal axis. If I say this is the lens, just take just representative image. If this is the focus, so the plane passing through this will be focal plane, okay? If this is the focus, all right? So this much is the, as we said, that it has large focal length. You can see this is the large focal length of the objective. So the image of the distant object is formed by objective in its focal plane, but this is the, as you see here, this is real. So what are the actions? Action is the objective. First, what it will do, objective will form an image, real, inverted, and so image formed by objective. So position will be focal plane, its focal plane, you can see this, the image is here, actually A prime B prime, you can see that A prime B prime. So this is the one, A prime B prime, okay? Image is formed at focal plane. Then what is the nature of the image? The nature of the image will be real, okay, and inverted. What about size? Size will be diminished or reduced sized, okay? The image will be diminished image, okay? So these are the nature and some informations of the image formed by the objective lens. Now look, the position of this eyepiece is so adjusted that the image formed by this objective will be coming within the focal length of the eyepiece. See, FE is the focal length of the eyepiece. This is the focal point. So this is the focal length. See, the objective has formed an image here. This position, let us say this is UE. This position, this particular position or distance is UE. So this UE is actually less than FE. That means the image formed by this objective is lying within the focal length of the eyepiece. Now you know what is happening, right? Then there will be a real image, virtual image formed by this eyepiece on the same side. See that virtual image is A prime, B prime. Okay, and in this case, you know, when the object is within the focal length, then the image will be enlarged, virtual, and erect image. So A prime, B prime, and A double prime, B double prime, these are actually, so this is erect image of this A prime, B prime, isn't it? And it is enlarged image. But we have adjusted such that this enlarged image or the final image is formed at the least distance of distant vision from the eye. So that is D here. So from the lens, since we keep the eye exactly or very near to the eyepiece, all the distances we measure from this eyepiece or this lens eyepiece will be measured from as if from the eye itself. So this is the final image. So here, you know, this B is actually minus D, the image position. And you look, this is the U, this is the object position. Okay, minus U for this eyepiece. Okay, so what we see for eyepiece then? Image formed by eyepiece. So image formed by eyepiece. What is that image? Here A double prime, B double prime, isn't it? So what is the position? So you know the image position is V is equal to minus D. That means at least distance of distant vision of eye. Okay. We have taken that our eyes having normal vision. That means this D will be something like 25 centimeters. And what is the object distance? Here object distance is U. E is equal to, U is minus UE. This is unknown so far. We have to find it out. And we know the focal length FE, right? We know the focal length. So here the image, what is the nature of the image? It is actually virtual, erect, and enlarged. Okay, these are the nature of the image. Okay, image formed by eyepiece. So you look, final image is actually inverted image. See, AB is like this. And see this A double prime, B double prime. So final image is real, inverted, and enlarged. Actually, this is what we'll see through the eyepiece. We'll see the A prime, B prime only. Intermediate image we will not be able to see. Okay, so when we see a distant object, astronomical object, we see this inverted image of that, which is enlarged and real in nature. Okay, and that, see, there are two settings. So the first setting is this one. The image will be formed at least distance of distant vision. Now see what is the magnification in this case. Okay, what is the magnification in this case? When the least distance of distant vision image is formed. So magnifying power, you know, we have already discussed the definition, so I'm not going to write it here. I'll just tell you. Magnifying power of a telescope is defined as the ratio of angles subtended at the eye by the final image formed at this distance of distant vision to the angle subtended at the eye by the object at infinity when we see directly on naked eye. So magnification or magnifying power, in this particular setting, what is the magnifying power of telescope? I think I have this figure. Okay, let me just take this figure for my use here, because I need to show you the angles. You look here. So magnifying power is defined as the angle subtended by the final image at the eye, right? When the image is formed at the least distance of distant vision. So that particular angle he is see, this particular angle is beta. So M is actually defined as angle subtended by the image at the eye when the final image is formed at the least distance of distant vision, beta, and divided by the angle made by the distant object at the eye when we see through naked eye. Okay, so that is alpha. Over here you can see that this one is alpha, this one is also as alpha. So since these angles are small angles, we can write this as tan beta divided by tan alpha. So look here, tan beta can be written as a prime b prime divided by a prime e. E is the center optical center of the lens eyepiece, and O is the optical center of the objective lens. And this one, see alpha, tan alpha can be written as, see a prime b prime, this triangle if we take this triangle, this one, a prime b prime over base will be O prime a prime. Okay, O prime a prime. All right. So a prime b prime see here, if we simplify, then we get O prime a prime divided by divided by divided by a prime e prime, sorry, a prime e. See here, O prime, see this O prime a, I'm sorry, not O prime, O a, O a prime. Look, this O a prime, this O a prime is nothing but the focal length of the objective lens, and with a positive sign here, isn't it? See, the distant object, image of the distant object will be formed at focal length, like focal plane in this case. So this a prime b prime is formed at the focus itself. Even if it is focal length, it is focus itself. So that's why O a prime we can take as FO, that means the focal length of the objective, and a prime e, this we have taken as the object distance A prime E, this is the one object distance as U we have taken. See this with the minus sign here. Okay. Then what is the magnifying power? FO by UE with the minus sign, so this will be minus. But this UE, this intermediate thing we will not be able to see. We will not be able to measure. So there is a trick to find out what is this UE. We'll use the lens formula in second case. So the image is formed is at minus D. So U is minus UE, and focal length we know. Focal length is FE for the eyepiece. Now if we use that lens formula, see I am just doing it here. 1 by V minus 1 by U is equal to 1 by F, formula for thin lens. So 1 by V is minus D, and this is minus UE is equal to 1 by FE. We have to find out this one. See what we get. 1 by UE is equal to 1 by D plus 1 by FE. So this is what we are going to get here. Okay, if we put it here, look, we'll go to the next page. So M will be, say M was like this, FO by UE. UE we have got 1 over UE we have got already. It is 1 by D plus 1 by F of E. Okay, so if we take the F of E common, it will be 1 plus F of E by D here. Okay, so this is, sorry, this here it will be multiplication. Okay, so what is the final magnification we have got in this case? When the object is formed, sorry, image is formed, final image is formed at least distance of distant vision of eye. So this is the final magnifying power or magnification. So you see here F of E is actually coming in the denominator, and here also it is coming in the numerator, but anyway this factor has more strength than this, because this is a 1 plus, that means there will be some decimal point coming up out of this factor. So if we just look this factor here, we can say if we want to have large magnification, angular magnification, then objective lens should have much larger focal length than the eyepiece. Okay, this condition has to be satisfied to have large angular magnification. Okay, to have large angular magnification or magnifying power. Here the negative sign is coming, right? What does this mean? This negative sign means real image, real and inverted image. Inverted image. That is what this minus sign is saying. Okay. So I'll just recap what we have done here. So we are discussing here the use of astronomical telescope in the setting when the final image is formed at the least distance of distant vision. Okay, so here what happens? Objective forms an inverted real image which lie within the focal length of the eyepiece, and that eyepiece then produce a virtual and erect image of that particular object. See, the image formed by the objective will act as object for the eyepiece, and then eyepiece will form final image for that particular object. Okay, or that image, we can say image of the original. So image of the original object will be acting as object for the eyepiece, and eyepiece will form the final image, that is real enlarged and inverted image of this object. And we have discussed, in fact we have derived the magnification power or magnifying power, that is m is equal to minus e fo by fe. Fe means the focal length of the objective lens, and fe means the focal length of the eyepiece, and this factor 1 plus fe by d. D is the least distance of distant vision. For normal eye it is 25 centimeter. And from this minus sign, what we are understanding? We are understanding that the final image will be real inverted image. And we can comment from this expression that if the focal length of the objective is made very large compared to the eyepiece, focal length of the eyepiece, then we'll have larger magnifying power of the telescope. Okay, so this was about the magnifying power at this setting. Now we'll see the other setting, that is when the final image is formed at infinity. So in this case, you know, the same thing is happening here also. The parallel rays incident on the objective at certain angle alpha, here you can see that. And at this case, the final image is similarly the the image formed by this objective will be real inverted. You can see that A prime B prime. This is the image formed by objective, and at the focal plane of this objective itself. But at this case, the eyepiece position of eyepiece is so adjusted that the image formed by objective is just falling on the focal length itself. That means this focal at the focus itself. So this is the focal length fe itself. So the image formed by objective is actually acting as an object for the eyepiece, and the position of the object from the eyepiece is now at the focus itself, focus of the eyepiece itself. And you know, when position of an object is at focus, the image will be formed at infinity, isn't it? And what will be nature? What will be the nature? Nature will be generally real inverted, real and inverted. Okay, real and inverted. So this is when the final image is formed at infinity. So now we'll be seeing what is the expression for the magnifying power in this particular case. So in this case, you know, magnifying power is defined. Magnifying power See how it is defined. It is the ratio of the angle subtended at the eye by the final image as seen through the telescope to the angle subtended at the eye by the object seen directly when both image and object will be at infinity. See, these angles are final image is forming angle beta, and the object when it is infinity, it is making an angle. See, the ray is making an angle alpha of the principal axis. So this is, and this is with the objective lens also. When you see directly, that means we are seeing from objective. You have to think that. Then here we can write, since these angles will be very small angles, so we can write similarly tan beta by tan alpha. See from here what we can write. See, if we take this particular triangle, then we can write it is a prime b prime by, let us say the optical center here is E, here it is O, this is b prime E, and in this case we will take this triangle. So a prime b prime divided by O b prime. Look then what we get, O b prime divided by b prime E. Look this, O b prime is nothing but the focal length of objective with the plus sign, and B E prime, this one is nothing but minus FE, focal length of the eyepiece itself with a minus sign. So what we get, magnification in this case or magnifying power in this case is FO by FE. So these are the formulas you have to remember. Okay. So in this case also you look, the magnifying power will be larger if your focal length of the objective is much larger than the focal length of the eyepiece. So this is all about astronomical telescopes and their uses at different footings or different settings. Okay, so I'm not going to repeat it here again. Similar way we have done. So just a overview what we have done. We have done what is called telescope. It is actually a device which is enabling us to see distant object clearly, and it actually increases the angular magnification of distant object. There are two types of telescopes. Okay, so we have learned what is telescope. Then types of telescope, there are two types. Okay, refracting, reflecting. Among refracting there are two types, astronomical and terrestrial. Reflecting we have not discussed today. We will discuss this in the next class. So among refracting telescopes, we have discussed astronomical telescope, which is there in the syllabus in like in NEET or JEE as well. So next class we will discuss this reflecting telescope and corresponding MCQs we will discuss here. Okay, related to these telescopes in the next class. Okay, so this will be done in next class. All right, so thank you for your patience. Bye for today. Thank you.